Welcome to the next video in the binary series. This video is also on multiplying binary numbers, but in this video we're going to use a different method. So in this video I'm going to go through how do we multiply decimal numbers using the traditional method. I'm also going to emphasize again how do we carry in binary, and then we look at some examples, and you will again have a choice to do some practice questions with the answers following them. So how do we multiply decimal numbers using the traditional method? So for example, you have to multiply 5,972 by 402. First and foremost, you pick out which one is the bigger number, you place that on top, and the multiplication sign, you place the other number at the bottom. Now, what we're going to do, we're going to multiply digit by digit. So the smallest digit is 2, so we're going to multiply the top number by that 2. 2 times 2 is 4, 2 times 7 is 14, carry the 1, 2 times 9 is 18 plus 1 is 19, carry the 1, and 2 times 9 is 10, add 1 is 11. Now, I deliberately record the carries on the sideways because when I move on to the next digits, I might need to do carry again, and if I start to note them in here, that will be just too much of a mess in here. And I suggest that you do that as well, because otherwise it gets a bit difficult to read. Now, so we multiply by the smallest digit. We need to move on to the next digit, but remember now, this is not a unit anymore, this is a 10 now. So first I need to record a 0, and then I can carry out the multiplication. But remember, multiplying anything by 0 will always give me 0. So that will be an easy one, because I just need to fill it in all with zeros. Okay, I can move on to the next column now. 4 is in the hundreds column. So at the moment, now I'm multiplying by 400. So I need to start with 2 zeros, and then I can do the multiplication digit by digit. So 4 times 2 is 8, no carry. 4 times 7 is 28, I write down the 8 and 2 carry. 4 times 9 is 36, plus that 2 is 38, so I write down the 8, carry the 3. And 4 times 5 is 20, add 3, gives me the 23. And the last step is that I have to add all these digits together. 4 and plus zeros give me 4. 4 and zeros give me 4. 9 and 8 give me 17, carry the 1. 2 plus 8 gives me 10, carry the 1. 2 plus 8 gives me 10 again, carry the 1. So that's 4 and that's 2. So that would be the answer of this multiple. Now, when it comes to addition and when it comes to carrying, in binary numbers, we have got 2 carries. The first carry appears when you have to add 2 ones together, then you record 0 and carry 1. And the other carry appears when we had 3 ones and we had to record 1 and carry 1. Now the question is, could we have more than these 2 options? And yes, once you have to add more than 2 binary numbers, carry can be more than these 2. So you need to be very careful on how to record these carries. And I'm going to show you practical situations when the carries appear, what we can and what we can't do. So let's look at examples. So let's say that you wanted to multiply 1, 0, 1, 1, 0 and 1, 1 together. So let's line it up the way that we would do with decimal numbers. 1, 0, 1, 1, 0. Multiply by 1, 1. Now again, it will be slightly simpler than carrying out multiplication in decimal, because the 2 digits I can have is just 1s and 0s. So when I multiply anything by 1, it's just itself. So I'm just copying down the first number. Now what I need to remember is that when I multiply with the next digit, that is one place value higher up. So again I have to start with a 0 and then just copy the same number again. 0, 1, 1, 0, 1. And now I can carry out the addition. 0 at 0 is 0, 1 at 0 is 1, 1 at 1 is 0, carry the 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 1, and I can just copy that down because there's nothing to add to it. So this number is the solution for this multiplication. 1, 1, 2, 3, 4 zeros, 1, 0. There were no extra carries here because we only had 2 digits to multiply. So let's look at the next example. 1, 1, 0, 0, 1 multiplied by 1, 1, 0. Now we have got 3 digits here, so the multiplication will be slightly longer. So again, copy the digits down, 1, 1, 0, 0, 1, and write the 1, 1, 0 underneath. Now, the first digit is 0. Anything multiplied by 0 is just 0. So I can write down all zeros for the first number. Then I move on to the next place value. Remember now this is the second place value. So the first place value I fill it with a 0. And then I start to multiply 1 and the top number together. Basically, just copy the number down. And then when you move on to the last digit, which is 2 place values away from the original, the first smallest place value, you put down 2 zeros and again just copy the number. Because again, any number multiplied by 1 just itself. So I have to add them together again. And although we had 3 digits, because one of them was 0, we can basically ignore the top row altogether because 0 doesn't add anything to the values. So I can just look at the bottom 2 and add those together. So 0, 1, 0 is 1, 0, 1 is 1, all zeros give me 0, 1, 0 gives me 1, 1 add 1 gives me 0, carry the 1, 1 add 1 gives me 0, carry the 1, which I can just copy down. So the solution for this multiplication is 1, 0, 0, 1, 0, 1, 0. The third example, 1, 0, 0, 1, 1, 0 multiplied by 1, 0, 0, 1. So again, write them underneath. And then carry out the multiplication again digit by digit. The first digit is a 1, so I'm just going to copy the original number down. The next digit is 1 place value up, so I need to start with a 0 because notifying that is a bigger place value. But this digit is also 0, so I can just easily copy all zeros into here. Same for the next place value. Now that is 2 place values away from the unit, so I need to start with 2 zeros. And because 0 multiplied by anything is always 0, I can just fill in with zeros. And the last place value is 3 place values away from the unit, so I'm starting with 3 zeros. And now it's a 1, so I'm just copying the original number. 0, 1, 1, 0, 0, 1. And now I will have to add them together. One quick way to check if you have done the lining up properly, if you haven't skipped any of the place values, is that you would end up with a kind of diagonal in here. So every number has to be 1 digit longer because you are always multiplying one bigger place value. So I have got a lot of numbers in here, but thankfully these two are all zeros, so they're not going to contribute to any addition. So 4 zeros is still 0, 1 and 3 zeros is still 1, same in here. Again, a lot of zeros, just gonna be 0. 3 zeros and a 1 is 1. 2 ones give you 0, carry the 1. 1 and 3 zeros give you 1. 2 zeros give you 0, and 1 plus nothing gives you 1. Okay, next example. 1 0 1 1 0 times 1 0 1. So again, copy the digits one under the other. And then carry out the multiplication digit by digit. So 1 times the number is the original number. When I need to multiply with the second place value, I start with a 0, and I notice that the second place value is a 0, so I'm just filling in all with zeros. And again, this is a 5 digits number, so I need to put 5 zeros. The next one is 2 place values up, so I'm starting with 2 zeros, and then just copy the original number because this is 1. And now I can add them together. 3 zeros makes 0, 1 plus 2 zeros make 1, 1 plus 2 zeros make 1, 2 zeros plus 1 make 1, 1 plus 1 makes 0, carry the 1, 1 and 2 zeros is 1, 1 and nothing is 1. So the solution for this multiplication is 1 1 0 1 1 1 0. Now let's look at the last example. 1 1 0 0 1 1 1 multiplied by 1 1 1. Okay, so copy the numbers one under the other. And then start multiplying. Well, every digits are 1, so I'm going to have to copy the number quite a few times, but not forgetting that when I'm moving from place value to place value, I have to start with zeros. So the first place value is just copying the number itself. The second place value is a 1, so I start with a 0 and then copy the number again. The last place value is also as 1, but that is now 2 place values away, so I'm starting with 2 zeros, and then I just copy the original number, the top number. And now I have to do the addition. What's going on in here? 1 plus 2 zeros gives me 1. 1 plus 1 gives me 0, carry the 1. Now, here is the tricky one, because I have got 1 and 1 and 1 and 1. Now, these two give me 0, carry the 1, and these two give me another 0 and carry 1 more. So, the 2 zeros give me 0, and then this way I was able to record the carries separately. The same situation goes in this column. So these two give me a 0, I can carry the 1, and these two again give me a 0, so I can carry the 1. So the small zeros add up to 0, and I have got all the carries I need in the next column. So 1 1 1 is 1, carry the 1. 1 add 1 is 0, carry the 1. 1 add 1 add 1 is 1 again, carry the 1. 1 add 1 add 1 is 1 again, carry the 1. 1 add 1 is 0, carry the 1, and you just write that 1 down. So I find it quite helpful for myself to deal with double digits separately and carry the digits separately, and that way I don't mess up. Some people can do 3 carries, so grouping 3 of those, and then just write down 1 and 0 here. That would give you exactly the same answer, because this would be a 1 and 1, but I just find it a little bit complicated, so it's easier for me just to deal with them as 2s. Another thing you can think about it, basically what I'm adding here together, this is 1, this is 2, that is 4. So I'm adding 4 plus 4 together, that makes an 8, and I'm adding another 4 and 4 together, that's make another 8. and the 2 8s together makes us 16. So actually I'm not carrying into this column, but I'm carrying into the column further. So some of the ways of doing this addition is not to carry the 1 straight into here, because these 2 again going to give me a carry, but just do 1 carry but 2 columns away. Again, I don't always able to follow that myself through, so I'm just finding it clearer for myself to do this multiplication this way. However, if you can follow those additions through, then just go for it, because then you probably have less carries in your calculation. Well, I hope that this helps you to carry out multiplications in binary numbers. Don't forget that there is another method. So if this method you find a little bit too complicated, you can always go back to the other method, which is the partitioning method. And now you can have a go at the practice questions. Here are the questions. And here are the answers.